While we consider stars, we likely imagine little reflective things in the evening sky. Basically, this is the image we see from down here on the planet. However, stars like Betelgeuse are something totally different. In fact, one of the most noteworthy stars, Betelgeuse, happens to be much greater than our Sun. For a significant period, this star has astounded scientists. Recently, something unsettling has been happening with Betelgeuse, making experts and other well-informed individuals extremely concerned. Join us in this video as we discuss the dramatic news about Betelgeuse and its impending destruction as predicted by the James Webb Space Telescope. We will also explore how this new development will impact our universe and our lives here on Earth, as explained by physicist Michio Kaku. Betelgeuse is an extraordinary wonder, a massive star that has captivated astronomers for so long. A Greek astronomer named Hipparchus was among the first to identify this star, which is so immense that it can be seen in the night sky from Earth, especially during winter. If you're into astronomy, you've probably seen or heard about this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and remains one of the brightest stars in the night sky. However, one thing about Betelgeuse's brightness is that it doesn't stay consistent. It fluctuates. This variability is one of the fascinating properties of this star, but it is not the only one. Let's look at some of Betelgeuse's specific properties. Most of the stars you see in the night sky are far from Earth. The nearest star is 4.2 light-years away. If you're not familiar with the term light-year, think of it this way. Imagine traveling at the speed of light for an entire year. It's been shown that light can cover a distance of 186,000 miles per second, so the distance light covers in a year is equal to 1 light-year. Calculating this, you'll have billions of miles. When we say the nearest star is 4.2 light-years away, it means it is billions of miles from Earth. However, some stars are significantly farther, and Betelgeuse is one of them. Betelgeuse is located about 600 light-years from Earth. If you were to travel to it at the speed of light, it would still take 600 years. We cannot move that quickly, not even with our fastest spacecraft. Yet, this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, it is due to its exceptional attributes, such as its size and brightness. Betelgeuse is nearly 1,000 times larger than our Sun, and its radius is believed to be hundreds of times that of the Sun. Unlike other stars that appear as small points of light, Betelgeuse appears as a disk when viewed through complex telescopes. This phenomenon is thought to be an effect of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse is around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 times 10 superscript 3 kilograms. Scientists cannot determine the exact mass of Betelgeuse because there are no planetary bodies orbiting it for comparison, and we cannot measure it directly from Earth. The fact that this star is several times more massive than our Sun makes it captivating. The brightness of Betelgeuse ranges from magnitude plus 0.0 to plus 1.6. In simpler terms, Betelgeuse is many times brighter than our Sun. No wonder it has been nicknamed a red giant. However, Betelgeuse's brightness doesn't remain consistent. It varies. This change in brightness is due to its pulsations. Betelgeuse expands and contracts. When it expands, it becomes brighter. When it contracts, it dims. This cycle can last from 10 to 100 days, or even longer. One of Betelgeuse's unique properties is that its surface is covered in dark magnetic spots. The magnetic field here is much stronger than on the typical surface. However, the downside is that these strong magnetic spots limit the flow of hot gas to the star's outer surface, making the star cooler in these areas. The fact that Betelgeuse has many of these spots, compared to our Sun, explains why it is cooler than our Sun despite its size and brightness. The Sun also has dark magnetic spots, but those on Betelgeuse are much larger and more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is many times stronger than that of the Sun. This field causes the gases on the surface of Betelgeuse to appear in spirals or arcs when seen through a telescope. Betelgeuse has a surface temperature of around 3,500 Kelvin. This low temperature contributes to the low energy output of the star and its dim red color. Although Betelgeuse is a red star, it wasn't always red. It was yellowish about 1 million years ago, much like our Sun. Over the years, its color began to shift to orange-red, and around 10,000 years ago, it gradually turned into the red star we know today. This fact has led scientists to believe that the star is aging. Betelgeuse produces up to 100,000 times more energy than the Sun. It would have been a formidable competitor to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen with the naked eye at night is quite impressive. Our Sun is just 8.3 light-minutes away from Earth, which is why it is so powerful. If Betelgeuse were a bit closer, we would be able to see it during the daytime too. But if it were to replace the Sun, it would engulf or displace Earth and the other 4 inner planets due to its enormous size. Even if it could match the Sun's energy output, it would still emit more radiation. Betelgeuse, also known as Betelgeuse, is a massive star located in the Orion constellation, about 600 light-years from Earth. Its enormous size is one of its most striking features. It is hundreds of times larger than our Sun. In terms of radius, it could easily envelop the orbit of Jupiter if placed at the center of our solar system. This giant size allows Betelgeuse to appear as a distinct disk rather than a point of light when viewed through powerful telescopes. Unlike most other stars, Betelgeuse is not the most massive star. Its mass ranges from about 12 to 20 times that of the Sun, depending on various estimates. One of Betelgeuse's most interesting characteristics is its variability in brightness. Unlike our Sun, which maintains a relatively steady brightness over time, Betelgeuse undergoes irregular changes in its brightness. These variations are attributed to pulsations within the star, caused by changes in its internal processes. At its brightest, Betelgeuse can shine 16,000 times more brightly than our Sun. However, during dimming episodes, its brightness can drop significantly. These fluctuations have been a subject of serious study among astronomers. Observations over centuries have recorded these changes, providing valuable insights into the star's life cycle and physical properties. Betelgeuse's surface temperature is relatively low for a star of its size, around 3,500 Kelvin. This gives it a distinctive reddish-orange tint, typical of red giant stars nearing the end of their life cycle. Betelgeuse is in a late stage of stellar evolution, where it has exhausted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena.